start chapter 3, we're going to start applying our rules of calculus to find the equation of the tangent to a given function, and we're often given the point so that we can then find it as an equation in a linear form, because a tangent is a linear equation. So for part A, we're going to firstly find the derivative of our function. So dy on dx is going to be equal to 3x squared take 6x. And once we've done that, we then want to be able to identify what the slope is at x equals 2. So our gradient is going to be equal to 3 lots of 2 squared, take 6 lots of 2. 2 squared is 4, 4 times 3 is 12. So our gradient at this particular point is 0. Now, once we've found the gradient, we are attempting to find the equation of that line. We now know that the gradient here is 0, so we're just finding a constant, which we can do by substituting the original x value of 2 into the original equation. So y is now equal to 2 cubed, take 3 lots of 2 squared, plus 2, 8, take 12, plus 2, which is negative 2. So for all of these questions, as long as we have both the slope or the gradient and the coordinates or point, we're able to identify the slope's tangent and the equation of that tangent. So because the slope was 0, our tangent is just going to make a linear horizontal line of y equals 2. Part B, we're going to do that same process, but we're going to need to do that using the quotient rule. So the calculus is a little bit more complex. But revisiting from chapter 2, we're going to have u equal to x squared, v being equal to 3 take x, and because there is a fraction, we're going to use the quotient rule. dv on dx will be equal to negative 1, and the quotient rule requires v squared, which we just put in brackets. So our derivative becomes the derivative of the first term times the second, take the first times the derivative of the second. Negative 1 causes this to become a plus x squared over 3 take x all squared. As was the case in the first example, we want to be able to substitute x equals negative 1 in. So our gradient is going to be equal to 2 lots of negative 1 is negative 2, 3 plus 1 becomes 4, plus 1 divided by 3 take becomes plus, so 4 squared is 16. Our gradient becomes negative 8 plus 1, which is negative 7 sixteenths. So we know the slope, we need to now also find the point at which that line occurs. So we substitute the x value of negative 1 back into the function. So y is going to equal negative 1 squared over 3 take negative 1, which gives us 1/4. And we can then use that information. So we've got 2 bits of information. Those bits substitute into our equation for our tangent. Y equals m is negative 7 on 16, lots of x plus c. Substitute in our point, 1/4 equals negative 7 on 16, lots of negative 1 plus c, and we can find our c value from there. At the same time, I'm going to say that is 4/16. Take the c, or move c across, we end up with negative 3 on 16. So our equation for that tangent ends up being y equals our gradient of negative 7 on 16 lots of x, take 3 lots of 16. Or the textbook sometimes will write that in the alternative form. Either of these two forms is fine.